Hello, we are Team 506 Pandara, one of the 3 teams from Palm Harbor University High School.
In the beginning of the year, we assigned roles to each of the members based on their preferences and skills. We split into designing, building, programming, and notebook subdivisions to allow for continuous progress on many aspects of the robot.
Initially, the design team favored 2 different methods of ball collection, a conveyor belt system and a bucket system. Ultimately, the bucket system was favored. Once we determined our method of collection, we prototyped.
Because we had multiple subdivisions in our team, we favored a modular design for our robot. This allowed us to have one group working on our drivetrain, while the other worked on the lifting mechanism, and a third was working on the bucket.
Our drivetrain is designed in a U-shape to give adequate space for the bucket. We use a mixture of chain drive and gear drive to allow for the space needed for the bucket. The bucket uses 2 servos to act as a scoop for the balls. The bottom of the bucket has a plate to filter out the small sized balls while lifting the larger balls. We did this because on average picking up the smaller balls led to a larger possibility of penalties and led to a lower score payout. The scissor lift is powered by a pulley system with an approximately 1:10 rotation ratio attached to 2 individual motors. This is because a large force is needed in order to lift the scissors. In addition to the scissor lift, we have a rotating arm that turns the bucket into a dumping mechanism. The 2 servo doors act as a natural funnel. Our strategy is variable depending on the abilities of our opponents and our allies. However, we mostly focus on scoring the 90 centimeter goal in the teleop period and the 120 centimeter goal during the endgame. If our ally can score in the 120 centimeter goal, we can also push up the rolling goals onto the ramp.
Initially, the filter on the bucket did not allow for the collection of balls. To fix this issue, we rounded the edges of the filter and updated the sweeping servos to be closed unless a button was pressed. This prevented balls from escaping the bucket.
Our drivetrain uses 4 motors to power each of the wheels separately. This is because we plan on switching to mecanum wheels, which will allow for the horizontal movement of our robot.
We demonstrated the various functions of our robot to the public at Mosey in order to introduce the basics of FTC of robotics. We also allow other teams to borrow our tools at the competitions and lend them our help when they request it.
Our robot is constructed of mostly recycled parts from previous years. This allows us to allocate funds to other matters. We also held a fundraiser at Outback Steakhouse to help fund replacement parts.
Our robotics club is only possible with the wide range of help we received from a variety of different organizations and our mentors. We'd like to personally thank Raytheon, Rockwell Collins, Advanced Systems, Pinellas County Schools, PTC, and Tampa Bay Technology Alliance for all the help they've given throughout the years. We'd also like to thank our mentors at PHOHS, Dan Kinzer, Jim Olson, Jeff Mogensen, Craig Ross, Adam Vierchuk, and Miss Fox. Also, we plan on holding Judgment Day at our school later in the season. We coordinate these events and community with our members using Facebook, email, and our website.